Hey everybody, welcome back. So we're just going to continue on. This is actually the same slideshow as the same PowerPoint as the last lesson. So if you worked ahead and maybe got a little confused, this should help clear it up. If not, that's fine. If you didn't, this is going to be the notes for 6.3b. So just to kind of recap what you should know at this point is how to solve these using the FOIL method, right? So first, outside, inside, last. Or you could use the shortcut if you understood the shortcut. There's nothing wrong with using it at this point. So let's just do, actually go ahead and pause this and just kind of write these in your notes. Make sure you're able to do it. Shouldn't take you more than a couple minutes, and then restart this. Okay, so if we're going to FOIL this, we're going to multiply our first and first, so that's x squared as usual, and our outside terms, so x and 8x to get 8x. And then our inside terms, 5 times x, and then our last terms, 5 times 8. Combine our like terms in the middle, and you see that pattern kind of recurring over and over again. So 13x plus 40. And just kind of go over the shortcut again. If you didn't get it the first time, it'll make sense this time around. So shortcut works like this. We already know the first term is going to be x squared, right? We also know that the last term is going to be the product of these two integers, right? So negative 6 times positive 3 would be negative 18. And then that middle term, after we do our FOIL and combine like terms, is just going to be the sum of those two numbers. So if I add negative 6 to 3, I get negative 3x. So that's the shortcut. So looking at this last one, you can kind of, the more you do it, the easier it becomes. If I add them, I get negative 15x. If I multiply them, I get positive 56. And the shortcut does help you with what we're going to do today, because what we're going to do is we're going to reverse that process. Okay, we're going to take a look at trinomials that are in the form of ax squared plus bx plus c. But these ones are special because we're going to focus on ones where the trinomials have an a value of 1. In other words, there's no coefficient in front of the x squared. Okay, these are probably the easiest ones to factor, mostly because of the shortcut. So if you understand the shortcut, this makes it a lot easier. All right, so we're going to actually undo the FOIL. Okay, we're going to undo the distribution and get it back. We're going to get this trinomial back to its binomial factors. All right, and the way we're going to do this is we're going to take that shortcut concept and look at a trinomial like this one, x squared plus 5x plus 6. And I know this is hard to see. The formatting got all screwed up. I'm going to fix this on my next slideshow. So what we're going to do is we're going to get in the habit, hopefully you get in the habit, of creating a little product list, okay, of all the different ways to make the C value. Okay, so identify all the factors of C. In this case is 6. So think of all the ways you can make a positive 6. It's not super difficult, right? It's 1 times 6, or we could do 3 times 2. You don't necessarily need to list them, but we could also do 2 times 3, and we could do 6 times 1. Those are all the different ways to make 6, right? So then what you do is you look at the B value, in this case, the 5, and you say, all right, well, which one of these products or factors that give me 6 add up to 5, which obviously would be 3 and 2 or 2 and 3. Either one, it doesn't matter. So important thing, we always get this question, does it matter what order we do these in? Not really, because of the commutative property. Because we're multiplying the binomials, it doesn't matter what order you put them in. So if we were to split this into its two binomial factors, hopefully you recognize from all the FOIL that you did that the first terms in this case are going to be x all the time. Okay. Then we look at what we identified here. I'll just use 3 and 2 as being our factors that add to 5 but multiply to 6. And those are actually our second terms for each of the binomials. And again, like I mentioned before, these are really easy to check because if you just do some mental math and FOIL this back out, you get back to the original trinomial that you started with. So x squared plus 5x plus 6. And so the natural question that I always get is, what if I put the x plus 2 first? Does that matter? And so that would be no, it doesn't matter. Because we're multiplying these two binomials, it's commutative, right? So it doesn't matter what order you multiply in, you still get the same answer. So it doesn't matter if you put the x plus 3 first or the x plus 2 first. All right, so here's a couple for you to try. I did this on purpose. So you're going to notice something for each of these as you go through them. Hopefully, well, go ahead and pause it and then try to spot the kind of pattern, see if you kind of get the idea of what I was trying to do here. Okay, so hopefully you notice that the third term, the C value for each of these was 27, or in this case, negative 27. But really, the same number that we're working with. So if I was trying to find all the ways to make 27, I could break it down into factors. I could say, well, I know I can do 3 times 9. I can do 27 times 1. And that's about it, right? I could do 9 times 3 and 1 times 27, but I don't need to duplicate work like that. So for this first one, I know that 9 plus 3 will give me 12 when I add them. So this becomes really easy to factor if I just list those as x plus 3 and x plus 9. And again, you could reverse those, it doesn't matter. Okay, for the second one, I purposely chose negative 27 because I want you to recognize that, okay, if we're doing a negative C value, then we have to account for that. So are we talking about a negative 9 and a positive, or sorry, a negative 3 and a positive 9? Or are we talking about a negative 9 and a positive 3? It does matter because we're looking for which one adds up to a positive 6x or positive 6. In that case, this combination is going to give it. So x minus 3 and x plus 9. Those are going to be my factors. And I'm done. Over here on this one, again, we have negative 27. So we have the same products, same factors, negative 3 and 9, negative 9 and 3. And we have a problem, right? Now, hopefully you struggle with this for maybe 10 or 15 seconds before you realize, okay, wait a second. There is not a combination of numbers that results in positive 12. And hopefully you remembered from the last lesson, we have a terminology for this, right? This is prime. It is not factorable. Okay, so that's basically what you're going to be seeing on the homework. You're going to see a series of trinomials where you have to factor them. There's going to be a couple of primes, so you got to watch out for those. So if you come across some that don't have any factors that add to b, the b value, then you know that it's not factorable. All right, a couple more, and I'm going to wrap this up. I wanted to spend the bulk of the time in class answering questions. So, plus this is not a super difficult topic once you understand the pattern, right? So, as I mentioned in 6.2, you always check for that greatest common factor first. So notice that all of these have a lead coefficient. This is called a lead coefficient. And it's called a lead because it is the coefficient in front of the highest degree term. Okay, so because we have a x squared, right? Standard form says it goes first. So that coefficient in front of it is called the lead coefficient. So in this case, we have a lead coefficient. You should always check for GCF first. So hopefully you recognize, all right, all three of these terms are divisible by 2. So if I factor that out, I get a simplified expression of x squared minus 6x plus 5. Okay, now the 2 is part of the answer. So make sure you don't just like let it disappear or, fall off the face of the earth sometime. So, but now what we're going to do is, let me change colors here. Now what we're going to do is we're going to factor just the part inside the parentheses. So we're going back to what we just did. So we're looking for the factors of 5 that add up to a negative 6. Well, 1 times 5 almost does it, right? But that adds up to a positive 6. So we actually have to make these both negative, because if I multiply them, I get a positive 5, but if I add them, I get a negative 6. So my factors end up being x minus 1 and x minus 5. And notice I have that 2 hanging out in front because it's still a factor of our original trinomial. All right, now for this middle one, numbers get a little bigger, but again, hopefully you notice we have a greatest common factor. Should probably change colors again. So in this case, our common factor is 4. So I'm going to write it outside. I'm going to divide all those terms by 4. So x squared minus 15x plus 56. So running out of room, so I'm going to do 56 up here. All my factors of 56. There's a bunch of them, right? So we've got 1 and 56, 2 and 18. No, that's not right. $28. We got a bunch more. You could list them all out, but what you're really looking for is the ones that add up to negative 15. So, what can we do? We could have had every single combination, including all the negative versions, right? That would take a while. Or, hopefully you know that 8 and 7 is 15. But in this case, we need to use negative 8 and negative 7. Right? You multiply them, you get positive 56. You add them up, you get negative 15. So that ends up being our 2 binomial factors. Okay. Third one, we've got a common factor of 5. So divide everything by 5. X squared minus 9x plus 20. Looking for the factors of 20 that add up to 9. Right, I'm not going to bother writing 1 times 20. I know that's not going to not be 9. 2 times 10, right? 2 times 10 could work. 4 times 5, well, there we've got 9. But, again, I'm looking for a positive product, but a negative sum, right? So I need to make these both negatives, and those will be my 2 binomial factors. Okay, and again, this is one of those things where the more you do it, the easier it becomes because you start remembering all your different product facts and factor facts, so it goes a little quicker. All right, so this is the last slide. I usually have you guys do this in class, so what I want you to do, if you indulge me, is to pause this. Think about this. If you're working with someone else, put your heads together. Could we come up with some rules for factoring these based off of their signs only? Okay, could you come up with your own rules? So pause it for a second, talk about it, think about it, and see what you think. Okay, so hopefully you came up with some patterns of behavior. And if you weren't sure what I meant by rules, this is what I meant. I know that if I have a positive C value and a positive B value, then the numbers I'm looking for are what? Positives, negatives, one negative, one positive. Well, obviously the only way to get a product and a sum that are both positive is if both factors are positive. And for this second one, I know that if I have a positive product, positive C, but a negative B value, Okay, so how do I end up with a positive product but a negative sum? Well, if both factors are negative. Okay, so these rules just kind of help you clue in on, okay, well, what types of numbers should I be looking for? All right, for the third one, if I have a negative C, so a negative product, but a positive B value, well, the only way to get a negative product is if one of them is negative, right? But which one, the bigger one or the smaller one? Well, to get a sum, okay, if I add them together to get a positive B value, a positive middle term, then the larger number is going to be positive. And that's the same thing for this last one. If I have a negative product, but in this case, a negative sum, well, then that means the larger is going to be negative. Now, do you need to memorize these? No, not really, because you're really just dividing and, you know, trying to figure out the combination of numbers that works. But these rules, not really rules, but these rules kind of help guide you to, I mean, not all the numbers are super obvious like the examples we did. You're going to see some larger numbers. You're going to see some products you probably haven't seen in a while, the ones that give you trouble, you know. So this makes it a little easier to kind of pinpoint and zero in on, well, what types of numbers I'm looking for. Negatives and positives, both negatives, just makes life a little easier. All right, so that is it for this particular lesson. Make sure you ask questions in the room if you got any questions.